What is a wave? We'll use the example of a Mexican wave to examine what happens with a wave. In a Mexican wave, the wave travels round the crowd while the individual people just bob up and down. The wave travels, but the medium, that is the people, stay where they are. Waves such as Mexican waves, sound waves and water waves, which move through a medium, are known as mechanical waves. We can also define them as a progressive wave. And a wave is a vibration of the medium which transfers energy without a transfer of matter, that is, without transfer of a solid, a liquid or a gas. As well as defining progressive waves, we also need to think about light waves and other electromagnetic waves. They don't need anything to travel through or on. They are not mechanical waves. However, they do have a lot in common with the other waves, and we can treat them all as progressive waves. So, light is a transverse wave, but it is a little different from other types of waves. It's not molecular motion, it's an electromagnetic wave. Now, you look at this in more detail if you go on to study physics at degree level, but for now you just need to know that we can treat light in the same way as we treat other transverse progressive waves, and all the definitions that we're going to learn for them will be useful for light as well. So, let's look at a transverse wave. A transverse wave is a wave in which the motion of the particles, which is going up and down, is at right angles to the motion of the wave itself, which travels along. That's a transverse wave, and you can see in the animation how the motion of the particles in the wave direction are at right angles. A second type of progressive mechanical wave that we look at is a longitudinal wave. Now, sound waves and some types of seismic waves are examples of longitudinal waves, and these are much harder to draw. A longitudinal wave is one in which the motion of the particles is in the same direction or is parallel to the direction the wave travels. And in this animation, you can see the motion of the particles and the wave. Okay. Now, you'll need to be able to define certain key terms, most of which are going to be familiar to you from GCSE science. So let's have a look at different waves. So here are some of the key terms you need to know. There's amplitude, wavelength, frequency, time period, speed, and phase. And then phase you won't have come across, and also path difference. Again, you won't have necessarily come across from that. So here we have a displacement distance graph. Displacement distance. The displacement of the wave is a measure of how far the oscillation is from its rest position, and we usually think the centre of the graph as its rest position. The maximum displacement of the wave is known as the amplitude, and this can be positive or negative. As you can see, it can be positive there or negative there. The distance between two identical points on the wave is known as the wavelength. We often draw this along the axis, as I've done here, but it could be drawn here or here. The wavelength is the same in each case. Now, we can link the frequency and the wavelength to work out the wave speed. But first here we have a displacement time graph. So this is different to the previous graph. And whenever you do questions using waves, then using these graphs, then you need to be very clear in your own mind what's on the axes. Make sure you know whether it's distance or time along the bottom. So here we have the amplitude. That doesn't change. But this time, the distance between the two peaks is the time period. And the time period is the time it takes for one complete wobble of the wave, or one complete oscillation, if we're putting it in the correct scientific terms. Now, the time period is equal to the 1 over the frequency. And the frequency, as you know, is measured in hertz. The time period is usually measured in seconds. Again, here's the wave speed. To work out how fast the wave moves, we simply need wave speed is frequency times wavelength, or V equals F lambda. You should know that from GCSE. And here are the units. Now, the phase of a wave is the position along the wave measured at an angle, and it's related to the position along the sine graph. Now, we don't normally need to know the phase of an individual wave, but we do need to know the phase difference between two waves. Now, if you have a look at the two waves here, you can see that A is slightly ahead of wave B. They're both moving in the same direction. In this case, the waves have the same wavelength, but they're not in step with each other. So we say that wave B is behind wave A by a quarter of a wavelength, or that B lags behind A by a quarter of a wavelength. If we think of the wavelength as a complete cycle of 360 degrees, then a quarter of a wavelength is a quarter of a cycle, or 90 degrees. So you may often see phase referred to as degrees or instead of wavelengths.